Hello, everybody. This is the third video on the same subject. That is the second order linear differential equations. And this part related with the non-homogeneous solutions of particle. This is one example that we are going to do it now. So this is the equation that we are going to solve. This is linear and second order because we have a second order derivative here. It's the solutions of that one is we've done in the previous videos. We know that we need to calculate the homogeneous part, and then we need to compute the non-homogeneous part. And the general solutions for the whole equation will be the homogeneous part plus the non-homogeneous part. So that's the structure. For homogeneous part, we will make this equation, the left-hand side is equal to 0. Find out the characteristic polynomial, find out the roots of it, and apply to the formula that is given in the theory to us for the solution. Characteristic polynomial for this part will be lambda squared minus 4 lambda plus 3 is equal to 0. It's a quadratic equation. We will split up to the linear factors. So that is lambda minus 1, lambda minus 3. Always check your linear factors satisfies your quadratic equations. That's lambda squared minus lambda minus 3 lambda. That will make it a 4 lambda minus 4 lambda. And 3 times 1 minus 1 times minus 3 is plus 3. That is correct. So this is a linear decomposition of the quadratic equations. Then we have from the first linear factor, we have lambda is equal to 1. From the second linear factor, we have lambda 2 is equal to 3. So if we have two distinct real roots. With the formula, the theory tells us that the homogeneous part solution will be given by e to the x some constant times e to the exponential function, the first root, times x plus some other constant e exponential function, second root of x. So this is lambda 1, which is 1x, and lambda 2 is 3, that's the 3x. And the a and b here are any real numbers. It's just a constant. Okay, so that was the solutions for the homogeneous part. Now we would like to do the non-homogeneous part. This involves a guessing function, as we discussed in the previous video. So this is a polynomial. 9x squared is a quadratic polynomial, which means that a polynomial of order 2. So how we can write a general polynomial of order 2? That is ax squared plus bx plus c. That is the second order degree 2 polynomials, a general degree 2 polynomials. That will be generalization for 9x squared. Then we have exponential, and we have 2. 2 is a polynomial as well. So we need to guess a polynomial. We can guess alpha plus beta x, or we can guess just alpha e to the x. In this case, this will alpha plus beta x choice will work. If your choice is not a good choice, you will not be able to find out a solution. It will be a degenerate form. In the end, it will tell you, and then you will just find out, and you will just choose guess another YP, and then repeat the computation again. This is how it goes. Okay, this is our guess function, the YP. So the idea is YP satisfies the equation. The equation involves the first derivative and second derivative, so we need to calculate the first derivative and second derivative of this function, substitute in this equation, and then to find out a, b, c, d, and alpha, beta. That's our aim. Okay, the first derivative of this with respect to x will be 2ax plus b. Yeah, and then we have this part. This part requires the applications of the product rule, because we have a function here, a polynomial depending on an x. We have a function here depending on an x. So you have two functions depending on both x. So we need to apply the product rule. So the derivative of e to the 3x is e to the 3x, and the polynomial is alpha plus beta x plus e to the 3x, and then we need to take the first derivative of alpha plus beta x is just beta. So that's there. Now we need to tidy up this a little bit, and because basically we are going to look at the second derivative of it, it will be easier for us to tidy up, and it will be much more less risky when we are doing a calculations, going tidying up will be a better idea. Okay, 2ax plus b is here. We have e to the x, e to the 3x, exponential function. Take the out and collect all this in one bracket. We have 3 alpha, that's coming from here, and 3 times beta x, and we have a beta here. Now we need to take the second derivative of this part. Second derivative of this part is just 2a. Second derivative of this part, again, we need to apply the product rule. Derivative of e to the 3x, 3 times e to the 3x times the whole polynomial 3 alpha, 3 beta x plus beta, plus e to the 3x, and then the derivative of inside. Derivative of inside is just 3 beta, which is that guy here. So if we tidy up, that will be 2a e to the 3x, and then we have 9 alpha, and we have 9 beta x, right? 9 beta x, and we have 3 beta here and 3 beta here. Altogether, we'll have a 6 beta. Okay, we have now yp, y prime p, y2 prime p, and we can substitute back. This is our original equation. Okay, next step, we are going to substitute all of them in. Y2 prime is this guy, 2a e to the 3x, 9 alpha, 9 beta x, 6 beta. And then we have minus 4 y prime p, minus 4, and that's y prime p, which is this guy, it's here. And we have plus 3 yp, plus 3, and yp is the whole of this, ax squared bx plus c, alpha plus beta x e to exponential 3x. Now, the key point here in our computation, we are going to simplify on the left-hand side, but do not do anything to the right-hand side. We want to make the left-hand side looks like to the right-hand side, such that we can make the coefficients are equal. Our aim is to find out the constants A, B, C, and alpha and beta. In that way we can. So the right-hand side we will think as 9x squared plus 0x plus 0 times 1 plus 2 times e to the 3x, which means that the coefficient of x squared, we will tidy up this place, coefficient of x squared will be 9, coefficient of x will be 0, coefficient of constant term on this side, on the left-hand side, will be 0, and the coefficient of ax squared will be 2. Okay, then, so the coefficient of x squared, we have only this term here, that is 3a, and the coefficient of x squared on the right-hand side is 9. So 3a is equal to 9, a is equal to 3. Now, the coefficient of x, there is where are the x's? X's are the green ones, right? This is minus 8a, there's a 1xa here, and I have another xa here, 3b, plus 3b, minus 8a plus 3b is equal to 0. That is the because the coefficient of x on the right-hand side is 0. Then we have 8, since a is equal to 3, substitute in, we will find b is equal to 8. Now, the coefficient of the constant term, which needs to be 0 on the left-hand side. Well, what are they? Where are they? So this is the constant term on the left-hand side. This is the corresponding to constant term. This is the corresponding to constant term as blue ones. Okay, 2a, that's right, and minus 4b, because this 4 multiplied by this, and then plus 3c is equal to 0. Then substitute a is equal to 3, b is equal to 8. Then we have 2 times 3 minus 4 times 8 plus 3 times plus 3c is equal to 0. We have 6c here. 4 times 8 is 32. 6 minus 32 will be 26. C will be 26 over 3. Now the next one that we need to do, coefficient of x on the left-hand side is equal to the coefficient on the e to the 3x on the right-hand side. That is 2. So what is the coefficient of e to the x's? So all of those, right? So we have 9 alpha, 9 beta, x, 6 beta from here. And then we have minus 4. We need to multiply this once by minus 4. Minus 4 minus 12 alpha, that's that guy here. Minus 4 plus, times 3 is minus 12 beta x. Minus 4 beta, minus 4 beta. Then we have this guy here, but we need to multiply with the 3. We have 3 alpha, 3 beta x. 3 alpha, 3 beta x. So this whole thing needs to be equal to 2. That's how we look. This is equal to 2. 2 is on the left-hand side, which is the coefficient of e to the 3x. This is the right-hand side. Left-hand side, the coefficient of e to the x, e to the 3x, all of those. And the right-hand side, the coefficient of e to the 3x is 2, which is that guy. Okay, what that does, so the green ones, 9 alpha plus 3 alpha will be 12 alpha, which will cancel out with the minus 12 alpha. We have 9 and 3 here, which will be 12, but we have minus of those items, so that will cancel out. Only thing that we left, 6 beta minus 4 beta, which will be just 2. Right, this is 2. 2 beta is equal to 2 will give us beta is equal to 1. Then alpha is a free variable. We didn't find anything about alpha, so we need to leave that as it is. So let's write it down, our non-homogeneous part solution, which is by p. So a is equal to 3, which is 3x squared, b is equal to 8, and c is equal to 23 over 26 over 3. Then we have alpha plus beta. Beta is 1, x e to the 3x. This is the non-homogeneous part solution. So for the whole solution, we have the homogeneous part plus the non-homogeneous part. Homogeneous part, we found that, and non-homogeneous part this. But we have the common factors. We have beta here, we have alpha plus xc here. So if we can collect them together to tidy up, we have beta alpha, b plus alpha plus xc here. B plus alpha is any constant because b and alpha are any constant. B alpha plus alpha is always any constant. So we can denote it again by b. So that this is b and that is x. So the solution, the simplified version of this will be a to the x plus b plus x e to the 3x squared plus 8x plus 26. This is the general solution to this equation. Okay, I will publish another solution on this subject in the next video. Thank you very much.